One of the most biggest problems in computer science is whenever you have a truth table with A being the output, and you want to easily convert it to a Boolean expression, such as A or B and not C, which basically means if A is true, then the entire thing will be true, or if B and C is not true. So if B is true and C is not true, then that will be 1. So this usually can take up to hours. So is there a faster way to do this? Well, yes. And today I'm going to take you through the methods. But first, what is a truth table? A truth table is like any other grid, where we have a set of inputs, A and B, and then we need to fill those input columns with all the possible combinations of inputs. Say, for example, 0, 0, 0, 1, 1, 0, and 1, 1. And then our output is derived from both the inputs being inputted and then a condition. So, for example, if our condition is A and not B, which basically means if A is true and B is not true, then our output would be true. Any other statement, it will be false. So, the only part where this is true is this one right here, where A is true and B is not true. True meaning on, which is a 1, and false meaning off, which is a 0. So now you have the basics. Let's go into the method on how you can easily derive that equation from the truth table. To start, let's say we have a table with A, B, and C as our inputs and our output labeled out. Now let's fill our inputs with all the corresponding possibilities and our outputs as so. Now, our goal is to turn this into a table like this, with our A and B column on the going vertical and our C column going horizontal. Now, I'm going to fill all the squares of the outputs, and let's explain this first, the A and B one. So, when A is 0 and B is 0, then that corresponds to this row of outputs. Now, our C one here, for example, this one here would be when A is 0, B is 1, and C is also 0. So now you understand the table. Let's see how we can turn this table into a Boolean expression. So as this first simple exercise, let's try and make a Boolean expression for this point right here. We know we can see A is true, B is false, and C is true. So we get the expression not A and not B and not C, which basically is if A is true and B is not true and C is true, then it's false because it's a 0. Now let's try and make a Boolean expression for this group of ones. We can see that both of the A's are off or false, and we can denote that as not A. And we can see our C is also false, so our expression would be not A and not C. And the reason we don't care about the B is because we just don't need it. There is no other reason why we should use the B in there. So let's try and make an expression for the entire table of ones. Now our goal is just to highlight the ones with as little rectangles as possible. So I've dimmed the 0 so we can focus on the ones. Now we know this one has an expression as not A and not C. And we can do this expression by looking at A is true, B is true, and C is false. So we can get A and B and not C. Combining those, we get not A and not C, or A and B and not C. And there's our final expression. So all you need to do for K-mapping, well, that's what it's called, K-mapping, is just find an expression that fills all the ones in as little possible rectangles as possible. So I hope you